In this video, we'll be talking about geometric sequences. At the same time, they are called exponential functions, and they have to do with the sequence that is being created by multiplying by a constant ratio from one term to another, so multiplying by a constant number. So in a geometric sequence, each term is found by multiplying the previous term by a constant ratio. So we have 1, 2, 4, 8, 16, 32, 64. Every number to the right was multiplied by 2. So I have 1 times 2 is 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2. So it's the same number multiplied times 2, 32, to be 64. So to find the next number in the sequence, what we have to do is multiply 64 times 2, and so on and so on. So to find any term of the sequence, we can use the formula y equals ab, or a multiplied by b to the x power. So the numbers will be y standing for any term. So let's say first term, then second term, then third term, then fourth term. A will stand for the zero term. So right here, when we look at this example, we have term 1, term 2, term 3, term 4, 5, 6, 7. But what was the one before? So the zero term is like the y-intercept if we were to graph this function, and it is the term before, which is usually not given in the sequence. In a sequence, the sequence starts with term 1, term 2, term 3. But what was the one before? So that is the one that is called zero term. So let's say, what would be the term before here? If the sequence is going up by multiplying by 2, then we have to go backwards. So if backwards means divide by 2, 1 divided by 2 will be half. So zero term will be half. Half times 2 will be 1. 1 times 2 will be 2. So this zero term right here, or the term before, is going to be a half. Common ratio is the number that is multiplied by. So in my sequence here, common ratio is the common number 2 that each term was multiplied by. The x will be the term number. So the x will be 1 if it's term number 1, 2 if it's term number 2, 3 if it's term number 3, so the term number. So what I'm going to do is I'm going to have an example for us that is the same exact numbers from the sequence above, and we're going to see how the formula works and how to find the 10th term of the sequence. So I like to have my sequence in a chart. So what we have in our sequence is 1, 2, 4, 8, 16. So 1, 2, 4, 8, 16. Common ratio being 2. 1 times 2, we said, is 2. 2 times 2, 4. 4 times 2, 8. So the common ratio will be 2. Those are the term values that we had in the sequence. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So we have 5 terms. So the term numbers are given 1, 2, 3, 4, 5. But what is 0? So we always have to make sure to find the y-intercept, or the starting point on the graph, or the 0 term. So right here, before my chart, before the 5 terms that I have to make sure that I have this 0 term. And how to find the 0 term? If in the sequence every number going up is multiplied by 2, then to go backwards, you divide by 2. So my zero term is going to be half. So in the formula, we have y equals a times b to the x power. Let's see how this formula works. Y is any term. So zero term is going to be calculated based on formula. A, which is the zero term half, times b, which is common difference, to the zero power. So here goes the first example. I'm going to just show how the formula works and prove it works. So I label it y0. Y0 is my zero term, equals my half times common ratio 2 to the zero power. Then I solve. Any number to the zero equals 1. Half times 1 is a half. So my term value for my 0 is half. X is 0, y is half. X, y. Now, check this out. So 0 term is half times common ratio to the 0 power. Any number to the 0 exponent is 1. 1 half times 1 equals half. So that one works. Let's see if the first term equals 1. How to prove that the formula works. So y1, I'm going to show that the first term is a, which is 0 term, half, times 2, which is common ratio, to the term number 1. So first term to the exponent 1. The term is the number 1. So half of 2, because 2 to the first power is 2, that is 2 over 2, which is 1. So this number checks out. Let's see the next one, just to prove that the term number y2 is 2. So this y2, in other words, second term, is calculated using the formula half, which is the 0 term, times common ratio 2 to the term number 2. 2 to the second power is 2 times 2, which is 4. Half of 4 is 2. That works. Let's check the third term. Third term means y3. Third term is calculated by 0 term, half, multiplied by common ratio 2 to the third power. So third term, third exponent. A is the 0 term multiplied by 2, common ratio to the exponent 3, which is the term number. That equals half of 8. Why 8? Because 2 to the third power is 8. 2 times 2 times 2 is 8. 8 divided by 2 is 4. So that term checks out. Let's do it again to follow the pattern. So fourth term should be 8. Let's see if the formula works. Fourth term is 0 term, half, multiplied by common ratio 2 to the fourth power. So fourth term is 0 term times common ratio to the fourth power. Half of 16, 2 to the fourth power is 16. 16 divided by 2 is 8. That's the number 8 right here. Fifth term. Fifth term is calculated based on formula 0 term, half, multiplied by 2 to the fifth power. Half of 32. Why 32? Because 2 multiplied by itself 5 times is 32. When the exponents or the numbers get bigger and bigger on the calculator, what we can do is instead of multiplying the 2 5 times, let's say 2, oops, so 2 times 2 times 2 times 2 times 2, that's 32. Instead of doing that a whole bunch of times, what we can do is use this function of the exponent, and we type in the base first, then the exponent function, then say fifth power, and that is 32 in one step. Okay, so in the directions it says find the 10th term, so that's going to be y10. 10th term can be calculated based on, again, 0 term multiplied by common ratio to the 10th power. So that's how it's going to look like. 10th term equals 0 term half multiplied by 2 to the 10th power. So this is where I'm going to use a calculator instead of multiplying 2 times 2 times 2 times 2 times 2. I'm going to say 2 to the power of 10 equals 1024. 1024, half of that, so I go divide by 2. 512. 512 is the value of 10th term in this sequence. If I look at the sequence, I have 1, 2, 3, 4, 5 terms. Another way, if you have not too many terms to find, let's say it's only 10th, so you can put more blanks here. So it's going to be 1, 2, 3, 4, 5, and then you go 6, 7, 8, 9, 10, and you keep multiplying to figure out the number. Or using the formula, any term can be found using the 0 term multiplied by common ratio times the term exponent. So let's see another example to notice how the formula works. So for instance, find the 8th term of the sequence. I have 1, 2, 3, 4 terms in this sequence. 2, 8, 32, 128. What happens from term to term? What is the common ratio that we have to multiply here? So I'm going to organize my sequence in the chart where I need to find my term 0. Always make sure that it is found. So 0 term is if in the sequence we multiply by 4, 2 times 4 is 8, 8 times 4 is 32, 32 times 4 is 128. Then to find 0 term, you have to go backwards, divide by 4. So 2 divided by 4 is 2 fourths, which simplifies to a half. So my 0 term is 1 half. Since the sequence is asking for the 8th term, what I can do, if I, let's say, forget the formula, is just keep multiplying by 4 all the way to the 8th term. So let's say 128 times, oops, not divide, 128 times 4 is 512. Then I keep recording. Times 4 is 2048. Then multiply by 4, and that would be 8,192. Then I multiply by 4, and that would be 32,768 Well, instead of doing that, I can use the formula and figure out what my number is. If I want to find eighth term, any term, I have to use the formula A, which is 0 term 1/2, times common ratio 4 to the term number 8. So in my formula, any term can be found using 0 term multiplied by the common ratio to the term number. So eighth term is going to be 0 term half multiplied by common ratio 4 to the exponent 8, because I'm looking for the eighth term. So doing that, I need half of, so exponent first, 4 to the 8th power. So I can go 4 times 4 times 4 times 4, or use a calculator and the exponent function, 8, which gives me 65,536. Multiplied that by half means divide by 2. So I'm going to put that divide by 2 in the calculator. And here's my answer, 32,768. So Y8, or term number 8 of this sequence, is 32,768. And that's what we have here after we multiplied and found all the numbers one by one. So if the term that you're looking for is not too big and the sequence is not too long, that way could be very helpful, or if you forget the formula. But this one is a whole lot more efficient if, let's say, in the directions it says find the 25th term, or find the 32nd term, or find the 100th term of the sequence. So then you're not going to draw a bunch of blanks. You are going to find the term number using the formula. So let's look again what happens in the next example. So find the 7th term of the sequence, and I have 12, 6, 3, then 3 over 2, 3 over 4. So let's see what is the 7th term. Here we have 1, 2, 3, 4, 5. So we need just 2 more, 6 and 7. But I'm going to use the formula this time. First, I need the 0 term. What is the common ratio? And common ratio in this example is multiplying by half. So half of 12 is 6, half of 6 is 3, half of 3 is 3 divided by 2. So in every multiplication, we have multiplying by half, which means same as dividing by 2. So if this way we multiply, the opposite, what would be the term before, will be divide by half. Dividing by half is like multiplying by 2. So 24 divided by 2 is 12, 12 divided by 2 is 6, 6 divided by 2 is 3. Or I can say 24 times half is 12, 12 times half, or half of 12, is 6, 6 times half, or half of 6, is 3. So my common ratio is a half. In the formula, to find any term, you need 0 term multiplied by common ratio to the term power, to the exponent that you need, 7 in this situation. So y7, in other words, 7th term, will be 24, which is the 0 term, multiplied by common ratio 1/2 to the exponent 7. Let's see how to work this problem. So we have 24 over 1, because it's a whole number, multiplied by 1 over 1 to the 7th power is 1, because 1 times 1 times 1 times 1 is still 1. So 1 to the exponent 7 is 1. And then on the denominator, we have 2 to the 7th. So 2 to the 7th power is 128. Twenty-four times 1 is 24, and then 1 times 128 is 128. So now we have to simplify this fraction. To simplify the fraction, we can divide by, let's say, 2, because they're both even, or we can divide probably by 4. Let's check if we can divide by 4 here. So 24 divided by 4 is 6, and 128 divided by 4 is 32. So we can divide by 4, and that would be 6 over 32. But they're both even again, so we can divide by 2, and that will be 3 over 16. And that cannot be simplified anymore. So our 7th term is going to be 3/16. And check out this pattern right here. Our common ratio is half, so we multiply by half. Half of 12, 6, half of 6, 3, half of 3. If you divide 3 by 2 is 3 over 2. But then if you divide again 3 over 4, that's 2 times 2, 4. So the next term should be 3/8, which is next term, if you multiply by half, 3/16. So 7th term here, 1, 2, 3, 4, 5, 6, 7 is 3/16 right here. Times half, times half, times half. And the last example, what if I have a table given to me? So the table below represents an exponential function of the form y equals a times b to the x. So I have the equation given, I have a table given. Complete the table and write the corresponding equation. So let's see how to work this problem. This time we actually even have the 0 term given in the chart. So this is in the chart xy, like you would graph on the coordinate plane, which we'll do next using our Desmos. So what I have is 0 term already given to me. Then I have first term is 12. So I know that this function is exponential. The table is showing the first two numbers, and in direction it says exponential function. So right here I can see my common ratio, which is multiplied by 4. So 3 times 4. So to fill in the next numbers, I will just multiply by 4. 12 times 4, 48. And then 48 times 4, 192. And then 192 times 4 is 768. So in the first part, all I had to do is determine the ratio that was used, knowing in the directions using the vocabulary exponential function, it means that I have to find the common ratio and then keep multiplying to fill in the missing numbers. Now the second part says write the equation that is represented by the values in this table. So to write the general equation, the x and y values will be dependent on A and B using the values in the formula. So the X and the Y are going to be present in the equation. The only number that is stable is A, zero term. That one we will replace in the equation with a number because it is a constant. It's the only zero term, and common ratio B. The y and x variables are depending on term number, but a is the zero term that I can replace with the number 3, and b is the common ratio that is 4, which is the multiplication from term to term. So to write the general equation for this table of values, I'm going to say to find any term for this table, what you need is the zero term 3, the common ratio 4, and then the term number for the exponent. So this is going to be the equation that is represented in the chart. So for any term, you need zero term multiplied by common ratio to the term number.